When we add and subtract unlike fractions, we first look for common factors, then we look for common multiples. In this clip, we're going to examine why it's so important that we always look for multiples first. So we're going to look at this example on screen, which is 2/15 minus 1/10. Now, in one of the clips, we explored the idea of being able to multiply the denominator of one fraction by the denominator of the other. Or in other words, using the type of cuts of one fraction on the other and then swapping that around so that we end up with matching equivalent fractions. So here we can see the 15ths have been cut up into 10 more times and the tenths have been cut up 15 more times. And so we're going to end up with 15 times 10 and 10 times 15. So we know that this is going to result in two equivalent fractions that are cut up into the same amount. And it'll be cut as shown. As a result of that, the number of pieces that we have in light blue would also be cut by those same amounts. So we'd end up with 20 150ths minus 15 150ths by doing this process. And that would, of course, give us 5 150ths, which is not the simplest fraction, so a little bit more work would go into that answer. This is not the most efficient way to do it, however, because what we should be doing instead is looking for multiples first. So looking at the multiples of 15, we have 15, 30, 45, and so on. And multiples of 10, we have 10, 20, 30, and so on. And straight away we can see very early on there's a matching multiple. The second multiple of 15 is 30 and the third multiple of 10 is 30. Therefore, we can simply just cut 15, each of those pieces, up twice. And we can just simply cut the tenths up 3 times. And that will give us a matching fraction type when we've done all our cuts. So if we look at the cuts now, having cut every piece in 2 for my 15ths and every piece into 3 for my tenths, I'm left simply with 30ths, a much less severe amount of cutting required. And of course, because I've done that, as always, I've done the same degree of cutting to the light blue pieces. So as I go through solving it, I would end up with just 4/30ths minus 3/30ths equals 1/30th. So I've ended up with a much easier, simpler process, less cutting involved, simpler numbers involved, and then once I'm finished, it's the most simplified answer that needs no further working. Now, the example shown in this clip is a very simple example. We only use tenths and 15ths, both of which are fairly simple fractions to work with. But already we could see the vast difference between doing the proper process and only needing to deal with 30ths, as opposed to just blindly following the rule of being able to use the partner as the number of multiples and ending up with 150ths. Now, when we're starting to work with larger and more complicated fraction types, this can balloon out into massive numbers instead of keeping it to smaller, more manageable numbers. So it's really important to keep in mind.